Physics chapter 18, video 3. So now in this figure 18.7 you can see a man on top of the earth. So why doesn't he sink into the earth or get thrown out of the earth? That is because the force that he exerts on the ground is cancelled out by the attraction to the center of the earth that is created on the man is cancelled out by the force that he exerts on the earth. So that is the reason why he does not sink into the earth. So now we need to understand what gravitational field strength, or G, is. Simple G. Gravitational field strength is defined as the gravitational field strength at a point is the gravitational force exerted per unit mass on a small object placed at that point. So that means a force is there, and this force is applying on a unit mass. So that means newtons per kilogram. So the units of gravitational field strength can be written as 9.81 newtons, very close to the earth's surface, right? So that is only for the earth, right? That is due to the earth's mass. There is a gravity of 9.81 newtons per kilogram, right? So this value is the same as the gravitational acceleration, which is 9.81 meters per second square, because there is a force. That force creates an acceleration. But it is to understand the field strength, it is easier if you take the units to be newtons per kilogram. So this because there is a force being applied per unit mass, you can take the equation of G to be G equals F upon M. Force is F is the force and M is the mass. I hope you understood that. So now from this we can actually take the units of simple G to be F is newtons per kilogram. Mass is in kilogram, right? So now we have two equations. This, for force we have an equation. Force equals G capital M simple M upon R square. Then if you combine these two equations, that is, instead of F, if you write G capital M simple M R squared, then F divided by M means G capital M simple M divided by R squared divided by simple M. So as a result you will get this equation, and that means you will end up with another equation for G, that is G equals capital GM upon R squared. So this equation is quite important for us. Simple G equals GM upon R squared, right? So now we learned what gravitational field strength is, and we know that it is equal to gravitational acceleration. And we know now the equation for simple G is capital G or into M divided by R square, right? So that means capital G is the gravitational constant multiplied by the mass of the object divided by separation. Let's see how this is going to be used. Since force is a vector quantity, it follows that gravitational field strength is also a vector. We need to give its direction as well as its magnitude in order to specify it completely. The field strength G is not a constant. It decreases as the distance R increases. So that is the separation between the object and whatever the other object on which the force is acting. Now for example, if this is the Earth's surface, and if there is an object here, the gravitational field strength simple G is the attraction towards the center of the Earth, somewhere below this point. Now if the object rises up, so the value of G reduces because this R increases, right? I hope you understood, right? the magnitude of G is about 9.81 newtons per kilogram. Even if you climb Mount Everest, which is 8.85 kilometers high, the field strength will only decrease by 0.3%. But if you go really up into the sky, then there is a decrease, a big decrease. So the gravitational field strength G at a point depends on the mass m of the body causing the field. Right? So that is the point that you need to understand. So the gravitational field will depend on the mass m of the body causing the field. So that means if you are talking about the earth and another object, so what causes the gravitational field is the earth causes on the object, if that is the way that you are going about it. The other object that is circling the earth, that will also have a gravitational field attracting the earth. But it depends on what you take as the main focus point. From there you have to do the calculation. Gravitational field strength also has units ms-2, that is the acceleration. Another name for G is acceleration of free fall. Any object that falls freely in a gravitational field has this acceleration, approximately 9.8 meters per second squared near the Earth's surface. Right? So we know how to use this G in different circumstances, and the acceleration in free fall, the equations of motion, you know how to use them, and you need to have a good understanding about those as well when moving into the question. So before we move on to the questions, I would like to give you the note. So please write down the note. Gravitational field strength G. Write down the gravitational field strength at a point is the gravitational force exerted per unit mass on a small object placed at that point. Leave a line and write. Therefore, G equals F upon M. Leave a line and write. As a result, it has the units newtons per kilogram, N, kg minus 1. Also, it has the units meters per second squared, ms minus 2. Because this force creates an acceleration, which is the acceleration in free fall. When this equation is combined with the force between 2-point masses equation, we can get the following equation for simple G. And please write down from here. If you have any doubts or questions, please raise them. F equals G capital M simple M upon R squared, and then you combine them. You write F is Gm simple M R squared divided by M means, then M to M gets cancelled out. As a result, you are left with simple G equals capital Gm upon R squared. Gravitational field strength is a vector because force is a vector. This strength decreases as the distance r between the two objects increase. When the distance is doubled, the field strength decreases by a factor of 4. Next point, put a star and write down. Gravitational field strength at any point depends on the mass m, capital M, of the body causing the field, and also the distance from its center, distance r, simple r, from its center. Right, so now if you look at this worked example, we will see how they ask questions. The earth has a radius of 6,400 kilometers. The gravitational field strength on the earth's surface is 9.81 newtons per kilogram. Use this information to determine the mass of the earth and its mean density. Right, use this information to determine the mass of the earth and its mean density. So let's use the equations we know. So before that, like I told you the other like I have told you in earlier videos, you have to write down the quantities that you know. So r is 6.4 into 10 to the power 6 meters, and g is 9.81 into 9.81 newtons per kilogram. So then we know an equation, g equals gm upon r squared. We know g is 6.67 into 10 to the power minus 11. We do not know m, that is what we are trying to figure out. We know that g is 9.81, and then divided by r squared is 6.4 into 10 to the power 6 squared. And when you simplify this, you will get m to be 6 into 10 to the power 24 kilograms. 6 into 10 to the power 24 kilograms. Then you use the equation for density, mass over volume. They have given the radius of the earth. Then using the radius of the earth, you have to find the volume. Volume of a sphere is 4.3 pi r cube. Then density rho equals mass over volume. Mass is 6 into 10 to the power 24. Volume is 4.3 pi into 6.4 into 10 to the power 6 to the power 3. And from this you can get 5,500 kilograms per meter cube. 5,500 kilograms per meter cube. I hope you understood. If you have any questions, please raise them. Now you will have to go into question number 3, 4, 5, 6, 7 and 8. Quite a few questions. So please make sure that you have understood everything properly before you attempt these questions. If you have any doubts, please raise them.